All right, just for the people who are absent, we're going to go over it pretty quickly. So we found out that the worksheet was missing a squared here, so we added our squared back in, and then we ended up, I think, getting the same answer, yeah? Yeah. Okay. So to find the distance, you substitute your points in, and yeah, for your x and for your y. It doesn't matter which one you put for x1 or x2, because when you square them, they all turn positive. And you should get 12.8 if you do 3 sig figs. Midpoint, guys, never ever look for the midpoint formula, because it's just common sense, right? The midpoint is halfway between, so it's the average. So just average your x's, average your y's, average your z's. You waste time trying to plug into a formula with midpoint. So that's exactly what you're going to do. I've lost my points. Here they are. Okay, so you average your 2 x's, and then you average your 2 y's, and then you average your 2 z's, and you get your points. Anybody have a question? Okay, so if we were graphing in 3D space, that is what we would be doing. Let's turn the page though. Okay, solids, formulas. There are a lot of formulas in your formula book. You will probably use your formula book more in this test than you have so far. But we need to know where to find them, so that like when you're taking your test, you're not like, where is that formula? So pull out your formula book and let's figure out where they are. There are going to be 2 different pages that have formulas that are going to be useful to you. So in your booklet on page 3, you have all the area and volume formulas from your prior learning. And where was the other one? Did I go too far? No. Oh, here it is. Yeah. SL 3.1. And it's page 7? Yeah. All right. So this has a lot of volume formulas, and it has surface area of a sphere. I see area and I see volume and I see surface area of a sphere. I don't see any other formulas for surface area. So that brings us to the next question. So we said that was pages 1 and 3, no, 3 and 7, right?
Yeah.
Wait, 7? Mine is 2 and 6.
That's what it is.
Okay.
Wait, are we ignoring the symbol?
I think I didn't have a, but like on the bottom there's a number. Sophia, what's the number? Does the number say 2 or 3?
It's 2 and 6. It's 2 and 6.
Okay. So if you're looking at the paper one, it would be pages 2 and 6, okay? So yeah, guys, what about this one? Why are there no surface area formulas other than the sphere? Because you can figure it out, exactly. Surface area is literally just the area of the sides, and the sides are made up of shapes, right? Like squares, rectangles, triangles, and so all you have to do is add up the surface sides. They did give you some things that are going to be useful. So like, let's see, surface area of a sphere, area of the curved surface of a cone. So that'll be useful because then you'll have the side of the cone, and then you just have to add in the circle there, okay? And there's some others back here too. So area of the curved surface of a cylinder is on here, and then you just have to add the circles on the top and the bottom. So surface area, there's a little bit more figuring out to do than volume. Okay. So surface area is just the sum of the areas of the sides. Surface area, I wrote SA for surface area, is just the sum of the areas of the sides. So we have a few things to work out here, and some of you like to figure things out for yourself, and that's super. I'm totally into that. I'll get you started though on the first couple, and then I'll give you a little bit of time. Sorry about my writing. It says surface area is just the sum of the areas of the sides. All right, find the outer surface area to 1 decimal place. So we're not doing 3 sig figs until it tells us differently. We're just doing 1 decimal place. And so here we have a cone, so we have to add the area of the side plus the area of the circle. So let's go back and grab that formula for the area of the side. I think it was down here. Area of the curved surface of a cone is pi r L. So I know what R is. What's L?
Probably length.
Yeah. So if you look carefully, it tells you that here. L is the slant height, and slant height means it's not the height in the middle of the cone, it's the height on the side of the cone. Okay, so they gave us that. They gave us the slant height, and they gave us the radius, so we can find that. So this is going to be for the side. And then the area of the base is a circle. And you can't see it, thank you. The area of the base is a circle. And if you look at your formula sheet, you should be able to find the area of a circle under prior learning. What's that formula? Pi r squared. So we're going to do both those things, and then we're just going to add them together. If it says 1 decimal place, they don't want you to answer in terms of pi, so you won't get an answer like 60 pi. You'll just get an answer with a decimal place in it. Okay, so I just told you don't give me an answer in terms of pi, but why have I written them in terms of pi so far? So I get the most exact answer, right? So keep it in terms of pi as long as possible, as long as reasonable, and then after that you can get your exact or your close to exact answer. So we'll do 60 pi plus 25 pi equals 85 pi. And when you're putting that in your calculator, do not do 85 times 3.14 because 3.14 is rounded, right? Every single number we put in for pi is going to be rounded because it goes on infinitely and there's no way we can type an infinite number. But your calculator has a bunch of digits stored, so let's use all the ones they have stored. So just type 85 pi in your calculator. And then you're going to round that to 1 decimal place. Did you guys get 267.0? Okay. What's my unit? Is it centimeters squared or centimeters cubed if I'm doing surface area? Squared, yep. Just think about the squares on the floor, right? Those squares are covering the surface area of the floor. All right, actually, I'm going to go through the 3 on this page before we look at any on our own. Okay, so the pyramid, for the surface area, I need to add up the sides, right? So what shapes are on the sides of the pyramid?
Triangles.
On the sides, they're triangles, right? And then on the bottom is a what?
Square.
It's a square. How many triangles are there? 4. So we're going to add up 4 triangles and 1 square. Four triangles plus 1 square is what I've written so far. It tells me that the height of the whole pyramid that's actually 10.8. I know the decimal is hard to see, so it tells me the height is 10.8 of the whole pyramid. But the height of the whole pyramid does not help me in finding the areas of the sides because it's not on the sides, right? What I really need is that slant height. The slant height will help me. Any ideas about how to find the slant height? There is. There's an equation we can apply.
Wait, you make a right triangle.
Can you make a right triangle?
Yeah.
Okay, let's do it. So here we're going to go to the midpoint of this side. All right. And I'm trying to find the slant height, which is L. For some reason, lowercase l looks just like 1 to me, so I always try to draw a cursive L for slant height. All right, and then what's the base of that triangle going to be? I heard a 6.6.
Yes.
Is that right?
Yeah.
Okay. Half of 13.2, so 6.6 here. All right, so L, I'm going to just work that out here. L squared is 6.6 squared plus 10.8 squared. $10.8 is the height. It looked like 108, but it's actually 10.8. Bless you. I know that that decimal was like practically invisible.
And there's like no space between them.
I know. I get you. If that were a test question, I would have taken either interpretation, but we're doing it together, so I'm gonna make it 10.8. All right. And then we'll do L is the square root of all that. Bless you. Yeah, so I get a lot of digits there, and if you can store that number, that's great. Or just keep it there so that we don't have to round it. But I'm going to write down 3 decimal places for now. So I'm actually going to write 12.657 for now. But if that's the last thing in your calculator, then we'll be able to use the answer button after that. All right, so now that we know that the slant height is 12.657 and more digits after that, and then we also know that the base of the triangle is 13.2, you should be able to calculate the area of the triangles and the areas of the squares. So go ahead and do that. I'm just going to catch up to you guys with some calculator work that you've already done. All right, and somewhere I stopped recording there, so I'm just going to go back real quick and say what I did. We found the slant height by solving the right triangle, and we got the slant height is 12.657. We used that to find the area of one triangle, so 1/2 the base times the height, and we multiplied it by 4 because there were 4 triangles, and then we added the area of the square base, which was 13.2 squared. And this is where we ended up. Any questions? I'm going to do one more problem and then let you work on a few. Yes?
How did you get the 334, 20, all that?
I'm trying to find that number. This number here?
Yeah.
It was 4 of the triangles. So one of the triangles was 83.5.
Yeah.
And then I multiplied it by 4 because there are 4 sides that are triangles.
And then what was the, plus 13.2 squared for?
So 13.2 squared is the area of the base, because on the bottom it's a square, and so it'd be 13.2 times 13.2.
Okay.
All right, for the cylinder, you really have 2 pieces. You have a single side. On the sides, you have a single side. Imagine that was like a canister. I don't know if you've seen like a canister of oats or a canister of salt or something. It has a label, and the label comes off. And when the label comes off the sides of that can, oh, like soup, right? What shape does it make? What? What shape? A rectangle, yes. So if you have a label on the can of soup and you take it off, right? You cut it and then you unfold it, right? It makes a rectangle. So when we're trying to find the surface area of the can, we're just worried about the rectangle and the top and the bottom. However, it says it has a hollow top and bottom. So that means there's no top or bottom. It's like a tube, okay? So this is all we're worried about. This is the 15 here. And you have a formula for the surface area of the side of the cylinder, and you can use that if you want, but it's kind of nice to know where that formula comes from, right? So think about it now. If that rectangle goes back around the can, then this distance here is really the circumference of the circle, right? This distance here is the same as the circumference of the circle, right here. And what is the formula for the circumference of a circle? 2 pi r, right? So then when you look at your formula booklet and it tells you that the side of a cylinder is 2 pi RH, well, that makes perfect sense. 2 pi r is the bottom part because that's the circumference of the circle, and the height is this part here, and the area of a rectangle is the base times the height. Yeah. So you're allowed to use the formula booklet. You don't have to understand why it works, but you're all pretty smart, and I think sometimes it helps to understand why it works.
So why isn't it just like 12 then? Because it's saying that the radius is 6.
Mhm.
The whole thing.
Yeah, all right, so Kaden points out we are ready to substitute in. Yes, absolutely. So we're going to put in 6 for the r, right? So it'd be 2 pi times 6, which is 12 pi. Very good.
But aren't we supposed to be doing it to 1 decimal?
So the base is 12 pi, the height is 15, so now we just have to find the area of the rectangle. 12 pi times 15, which gives me 180 pi, and then we're going to put that in the calculator.
It says to 1 decimal place.
All right, did you guys get 565.5? Okay. Okay, so in 4, it says write an expression for its outer surface area in terms of R. And so because it's a pipe, it still doesn't have any circles on the top or the bottom, so we don't have to worry about that, just about the sides. And some of you guys found the formula for the surface area of the curved surface, and it was 2 pi RH, right?
Yeah.
Yeah. Okay. So I drew a picture of that as well. 2 pi r is the base, h is the height of the pipe, but the pipe says it has a length, not a height, right? And that's just because the pipe is like turned on its side. So the height is the length. So the height is equal to 3 times the radius, so it's equal to 3r. So in this formula for surface area, I can substitute 3r for the h.
Sorry. Wait, what's the
Okay, did you guys do that? Did you substitute 3r for the h? Okay, then we'll combine what we can. So the surface area is 2 times 3 is 6 pi. And then what's r times r? R squared. Good. Okay, I'm going to stop there and ask questions. Ask 4 questions. What questions do we have? Okay.
Wait.
Yes.
Wait, can you explain that again?
Sure.
Like how you got from that one to that one.
Okay. So this is the formula in the booklet. And it had a height in it. And our pipe has a length. And the height is the length. Okay, so the length is 3 times the radius. So we put that for the height. And then we just multiply the 2 and the 3. And r times r is r squared.
Wait, why can't you?
Why can you multiply 2 times 3?
Is it because they're all multiplied?
Yeah, everything's being multiplied.
So you, okay, because that's
Now, like some people didn't do that.
why is it squared?
And the squared is because r times r is r squared. And if you didn't do this and combine those numbers and everything, then you could still have gotten this next part right, but the first part you probably wouldn't have gotten full points for it on the test because you didn't get the formula in its simplest form. Okay, so if you didn't do that extra step, go back and do it. So now it tells us what the surface area is, so we can substitute that number for the surface area. And when you saw that you can divide by 6 pi in the beginning, And if you want to write down enough numbers, you can put that in your calculator right there. But if you don't want to have to write down all the digits, then you could next say that r is equal to the square root of all of this. Let's see. 301.6 over 6 pi. You will need parentheses around that denominator to keep the 6 pi together. And it still is in the rounding to 1 decimal place, so I got 4.0 meters. Anybody else get 4.0 meters? Okay. Two pieces is that anything that's covered up is not included in the surface area. So for the cylinder, we need the side and we need that one base. For the cone, we need the side of the cone, but not the base because it's like stuck on the cylinder there. So imagine you were painting it and the sides that you would paint, those would be the ones that we would include. So we're going to do the area of the cylinder side. Cylinder side. And we'll do the area of the cone side. And then we'll do the area of one circle base, the one that's at the bottom. And those all have formulas in the formula booklet. So for the cone, it was pi r times the slant height. And they give us the slant height. So that'd be pi times 4 times 8, which is 32 pi. And you can make it a number if you want to, but I like to keep it in terms of pi until the end. All right, the cylinder side is 2 pi RH, right? 2 pi times 4 times 10, which is 80 pi. And then that base at the bottom, which is a circle, is just going to be pi r squared. And then to find the surface area, we just add them all up and then use a calculator to get 1 decimal place. And I got 402.1 square centimeters. Can anybody confirm that? 402.1 square centimeters? You got that? Somebody said yes. Thank you, Sally.
Should we do this?
I like them, but no, because they ask you to give the answer to 1 decimal place, so you don't need to. I personally like them because it's not exact. Yes?
Is the reason why you're leaving like the pi in the area?
Mm-hmm.
Is that like to have less decimals? Or is it like
Yeah, no, yes, so that you don't lose any accuracy by rounding. So you could round it, but you could write down all the decimal places the calculator gives you, but that's a lot of writing too. So it also saves me writing. All right, volume. They give you the formula for the volume of a sphere, and you just substitute in. It's pretty easy, right? Did anybody already get past the sphere? Okay. So, volume of a sphere, was that in your prior knowledge section, or was that in the new section on your formula sheet? Is it on page 2?
On page 3 and page 7, the volume formula.
Okay, yeah. So in your packet, it's page 2. Online, it's page 3. And the volume formula is 4/3 pi r cubed. All right, and then 4/3 pi times 18.2 cubed. Oh, it's not 18.2. What did I do wrong? I didn't do the radius, right? What should that be? 9.1 cubed, right? Because it says R, it doesn't say diameter. Okay. And if somebody could please put that in their calculator and tell me if you can confirm my answer or not. You get the same thing, Andrew? Yeah. Okay, when you're done with that, turn the page. We're going to do, bless you, the volume of a prism. So a prism is going to have all the sides the same, but it has two identical bases, one on the top and one on the bottom. So you could have a prism with a triangle base, you could have a prism with a rectangle base. Technically a cylinder is a type of prism because it has those, but they'll never call it that, they'll call it a cylinder. But it's really the same thing. The volume is the area of the base times the height, as long as your two bases are the same. So looking at this prism, even though it's turned on the side, the bases are the triangle, because the bases are going to be those two parallel things that are the same shape. Okay? So volume is area of the base times the height. All right, I need to find the area of that triangular base. And the formula for the area of a triangle is 1/2 base times height. So what part am I missing?
Height.
I'm missing the height. Can I find it? Yeah. So this whole thing is 12. This is 6. This is 10. So what's our height going to be? Yeah, so Sophia's saying we can use the Pythagorean theorem. This is also a case of a special right triangle. Do you guys know the special right triangles? Oh, I know what you guys are thinking of. Actually, those are the special right triangles. This one is, I think this one's called a Pythagorean triple. It's basically when you have three integers that will fulfill that a squared plus b squared equals c squared. So the most simple one is the 3, 4, 5 triangle. 3 squared plus 4 squared equals 5 squared, right? 3 squared plus 4 squared equals 5 squared. And any dilation of that triangle also works. So this is a dilation of the 3, 4, 5 triangle. And if you recognize it, it saves you time, but you don't need to, right? So 3 times 2, 5 times 2. So this one must be what? It must be 8. But you didn't know that, right? And that's okay. So if you're taking a test and you don't know that, then you just do Pythagorean theorem. 6 squared plus x squared equals 10 squared. And then you get x equals, when you solve it, 8. All right, so the triangle is 1/2 base times height. My base is 12. And my height is 8. And then the height of the whole prism, this is the height of the prism. Is 30. And I got 1,440 cubic centimeters. Can anybody confirm that? You got that? All right, go ahead and do 8. So if you substitute what you're given into your formula, you should be able to isolate the r squared just by dividing. And then do a square root. When you do a square root, if you want to put this all in your calculator at once, please make sure you keep that denominator together with some parentheses. So I'm getting to 3 sig figs because it says that here. It switched us up. I'm getting 2.10. Anybody else get 2.10? Okay. Just add the 0 so I don't have to worry about it. All right, capacity. Capacity is when you change cubic meters to kiloliters. KL is kiloliters. This chart makes it look confusing, but it's actually quite easy. 1 cubic centimeter is 1 milliliter. 1 cubic meter is 1 kiloliter. If you get cubic millimeters, then we got to do some conversions. But other than that, we're good. Okay? You can, of course, change cubic meters to liters, but you don't have to. So in number 9, it says find the capacity of a tank, and because it's just giving us those dimensions, we can assume that that is a rectangular prism, and so your volume is just length times width times height. That's it. So volume, length, width, height. All right, so go ahead and put that in your calculator, and we'll get an answer in cubic meters, and then we'll change it to a capacity measurement. Now, we didn't get a rounding on this, so I guess we should do 1 decimal place since we don't have a rounding, and that's tricky because it depends on if we're doing kiloliters or liters. I'm going to multiply it again. 2.6 times 3.1 times 1.45. Okay. Oh, so I'm getting 11.687 cubic meters. So cubic meters can translate into kiloliters, right? A cubic meter is a kiloliter. So you could say 11.7 kiloliters, or if you want to change it to liters, you multiply it by 1,000. That would move your decimal place over, and we would keep the numbers. So it would be 11,687 liters. So if it tells you to, I guess I would do 0.0 liters, but you get the idea. If it tells you kiloliters, if it tells you liters, you would put answers like this. Right now, I would accept either one because it just asks you to do capacity. One more problem. And then we're going to do an exit ticket. All right, 17.3 millimeters of rain falls on a rectangular shed roof. This is a little bit weird because it's a rectangular shed roof and that doesn't usually like have a side to it, but that's what they're imagining. So it's a length of 10 meters, a width of 6.5 meters, and then a height of 17.3 meters. So this is your shed roof. It's in a rectangle, like that, right? So we said 10, 6.5, but it also has, that's meters, right? A height, and the height is in millimeters. How many millimeters are in a meter? 100 centimeters, because remember the word cent means 100, right? So how many millimeters? 1,000. So what we're going to do is take 17.3 and divide it by 1,000. And I believe we're going to get 0.0173. Did anybody divide it yet? 17.3 divided by 1,000. Do we get 0.0173?
Yeah.
Okay. So that height there is 0.0173. So to find the cubic meters of rain, we're going to find rain is equal to 10 times 6.5 times 0.0173. And I'm keeping all my decimal places for now. And let me know if you can verify my answer of cubic meters of rain. All right, and then it says what happens is the water goes into this cylindrical tank with a base diameter of 4, and they so helpfully remind you that means the radius is 2 down here. How many millimeters does the water level of the tank rise? Yeah.
I actually just want to say I got something different.
Mhm.
I got 11.245.
Did you put a 0 in here? Did you do 0.0173?
I did 0. Oh wait, that's what I meant.
Okay. Thank you for telling me though, because I count on you guys checking me. All right. So the volume of the tank is going to be, there is a formula for the cylinder, but it's still the area of the base times the height. So the area of the base is pi r squared, and then the height of the cylinder. And the volume in the tank is going to be this number that we just found. This is how much rain went into it. The radius of the base is 2. And the height is what we're trying to find out. How far did the rainwater go up? So all we have to do is now divide by 4 pi on both sides, and we should be able to find out in meters how high it went up, and then we'll have to change that over to millimeters. All right, so again, how many millimeters in a, oh, does it say millimeters or centimeters? Oh, it says millimeters. That's interesting. I made mine in centimeters. How many millimeters in a meter? Still 1,000, right? So let's multiply this number by 1,000. 10, 100,000, yeah. Thanks, Sophia.